Okay, hi everyone. I'm going to start with non-F, differentiating powers with negative indices. Since we have already been talking about those before in class, so I hope you guys already know how to differentiate, expression with powers, like, expressions with powers that is negative. Okay, so in this case, I think, I'm just going to try a few questions from the exercise and show you a few more like an example questions. And so we should be able to finish this one very easily. It shouldn't be a very hard exercise to do. All right, so as you know, when we're differentiating normal expression, for example, x to the power of n, that n is just an integer, right? So the formula is like, if we differentiate x to the power of n, the answer is equal to, you move the n to the front, that becomes n, x, n minus 1. Now this n is any integers, so it can be positive or negative, so it can be anything, all right? So n is an integer, n is an integer. It didn't say n has to be a positive integer, so therefore if n is a negative number, you can still differentiate it without any problem. An example of that would be very simple. If I want to differentiate x to the power of minus 5, the way to do that is the same. You move the 5 to the front, minus 5, x, and you minus the top power by 1, so that becomes minus 6, and that gives you the answer. So it shouldn't be a very hard question to do. All right, so I'm just going to pick a few questions from the textbook. All right, so more towards those application type of questions. So let's have a look at the textbook questions here. The first question I'd like to do is question 8. Okay, question 8, C, 8C. So this question here. All right, question 8C. So I'm just going to write questions on this side. 8C, hope everyone can see it. Otherwise, you can obviously use your exercise, check your textbook. All right, 8C. We need to differentiate the y equals 2. So we need to find the derivative of square root of x minus 1 over square root of x and everything to the power of 2. Okay, so in order for us to differentiate this one, as you can see, we've got, square root. We also have a 1 over square root. So before we do that, we need to expand the power first, right? So we've got a power of 2 there. So let's just expand the power. I'm still going to write d over dx. Need to expand. All right, that's a perfect square. So therefore, that gives you x minus 2 times by square root of x times by 1 over square root of x plus 1 over x. All right, so that would be the expansion. And then to simplify this one here, that gives you x minus 2, because square root of x times by 1 over square root of x, that cancels out, plus 1 over x. All right, now here we go. So we can actually see this is where we introduce a negative power for the second term, for the last term, as you can see here, that's 1 over x. Now it becomes x to the power of minus 1. So once this is done, you can now differentiate each term by term. The derivative of x just equals to 1. The derivative of constant number is equal to 0. And the derivative of x to the power of negative 1 is you move the negative 1 to the front, and you minus the power by 1, so that gives you negative 2. So overall, the answer will be 1 minus x to the power of minus 2, and that will be the answer. You're feel free to change this power to a positive power, and then you just introduce a fraction if you want to, but I decided not to. I prefer to leave the answer like in terms of negative powers. All right, so that's how you do question 8C. All right, I would like to try another question from the textbook. Let's have a look what's the best one to do. I think I will do question 9B. Okay, question 9B here. All right, so which is this question here. All right, so let's have a look. The question asks us to differentiate it, then find the coordinates of any point where the tangent is horizontal. Okay, all right, so we'll start with this question. Question 9B. So we need to differentiate that one. So y equals to negative 3 over x to the power 4 minus 2x squared minus 1. Okay. All right, so the first step we need to differentiate. We need to find y dash. The second step, we need to actually find the x value where the tangent is horizontal. Find the value of x where the tangent at that point is horizontal. Okay, all right, so let's start. So obviously the first step we need to do is we need to differentiate it. All right, okay, so first step, all right, in order for me to differentiate this, I need to change that one into negative power there. So I am going to put -3 bracket x to the power 4 minus 2x squared minus 1 to the power of -1. Okay, now we should be able to differentiate that quite easily. We'll move the -1 to the front. We'll minus -1 by 1. That's how we do it. All right, so that gives us 3 bracket x to the power 4 minus 2x squared minus 1 to the power of -1. And then don't forget the chain rule. So what we also need to do is we need to find the derivative of what's inside. Okay, so we need to find what's the derivative here. And that becomes 4x to the power 3 minus 4x bracket. Okay. All right, so once we have finished this, looks like this time it's better to actually change into a fraction since we need to solve later, we need to solve for equation. So I'm just going to put this one into a fraction over x to the power 4 minus 2x squared minus 1 to the power of 2. Okay, so that is the derivative. Now, okay, the next step, what the question asks you to do is we need to find the value of x where the tangent is horizontal. All right, the key word here is horizontal tangent. Horizontal tangent means the derivative or the gradient function. Remember, this is the gradient function. Okay, gradient function. So we need to make sure the gradient function or the derivative is equal to 0, so we get a horizontal tangent. So therefore, the second question here we need to do is we just let 4x to the power 3 minus 4x over x to the power 4 minus 2x squared minus 1 square equal to 0. Okay, so now we should be able to solve this equation. Obviously, the denominator is never equal to 0, so we'll let numerator equal to 0. And we can always factorize the 4x out. That gives you x squared minus 1 equal to 0. So at the end, we should have 3 answers: x equal to 0, x equal to 1, x equal to -1. And those are the 3 values where the derivative or the gradient of tangent at those 3 points is going to be 0. Okay, so we're going to have turning points or stationary points at those values there. All right, so that's how you do question 9b. Pretty interesting question here. All right, let's have a look at another one. It's a good one to do. Okay. This time, I guess I'm probably going to do question 11. The question 11 says, find A if the tangent to this function at a point where x equal to 6 has a gradient of -1. Okay. All right. So let me just write down the question first. So question 11. Now the question says, we need to find the value of A. We don't know what A equals to. But then we know that gradient at x equal to 6, the gradient of tangent at x equal to 6, is equal to -1. Okay, so in the gradient, so I'll just say m at x equal to 6, all right, is equal to -1. Okay, so here's the information we have. Let's start to do this question. All right, so in order for us to do this question, if you see gradient, all right, I guess the first thing you do is differentiate. So we need to differentiate this function here first. All right, so before we differentiate, I need to change this one into a negative power, like -1. All right, and then y dash is equal to -1, x plus a to the -2. All right, and then I will probably need to change this one into a fraction, so we can solve the equation later on. All right, now remember what we need to do is we need to find the value of A, okay? With this information, we need to find the value of A. All right, so at x equal to 6, that means we substitute the 6 back into this x here, and then the gradient is equal to -1, which means the y dash is -1, okay? So these are the information we have. So we're going to sub x equal to 6 and y dash equals -1 into the above equation here. All right, into y dash equals to minus 1 over x plus a squared. So from here, we should be able to solve an equation quite easily. So minus 1 is equal to minus 1 over x, or no, x is equal to 6. So 6 plus a squared. Okay, so we now need to solve this equation. X plus a squared is equal to 1. 36, 12a plus a squared is equal to 1. So a squared plus 12a plus 35 is equal to 0. So a plus 5, a plus 7 is equal to 0. All right, so a is equal to minus 5 and a is equal to minus 7. That should be the answer for this question. All right, so that's question 11. Again, pretty straightforward. Not really hard. Okay, all right, so I guess I'm probably going to do maybe the last question, question 15, and that should be enough for you to actually do the remaining of the question there. All right, so question 15. What does question 15 tells you to do? Show that the hyperbola xy equal to c squared can be described by the two parametric equation. All right, okay, so that's the first one. And then differentiate parametrically to find the gradient at a point t equals to that with parameter t. Find the equation of tangent t. Prove that x-intercept a of a tangent, the origin of O, and the original point t forms an isosceles triangle. Okay, so it takes a while to do this question here. All right, so let's just do it step by step. 15a. So what we need to do first is we need to prove where we have those parametric equations c x equal to ct, and then we have y equals to c over t. Then we need to show the hyperbola xy is equal to c squared. Okay. All right, so we have Cartesian parametric equation. We need to form a Cartesian equation. That's what we need to do for the first question there. All right, that's pi. All right, it's pretty easy. That's equation 1. That's equation 2. You can start from either equation. Doesn't matter which one. If you start from the equation 2, t is equal to c over y. Okay, so once you finish that, then you can substitute t equal to c over y back into the equation 1. So therefore, x is equal to c times by c over y. X is equal to c squared over y, and the xy is equal to c squared. Okay, so the part A is pretty straightforward. Now, part B, the question asks you to differentiate parametrically to find the gradient at a point t equals to that number with parameter t. All right, so we're going to differentiate parametrically. All right, so question B, x equal to ct, y equal to c over t. All right, so we need to differentiate this one parametrically. So we'll do dx over dt first, and that is equal to c. That's pretty straightforward. The next one is dy over dt. Okay, and then, now this part is a bit tricky, this, okay? C is a constant, t is the variable, so if you want to differentiate that, we need to change that to the negative power. So that gives you negative c t to the power of minus 2. All right, once you have done that, all right, we need to find dy over dx. So dy over dx. Using the chain rule tells us it's equal to dy over dt multiplied by dt over dx, which is the reciprocal of that, as you can see that. All right, so therefore that gives you minus ct squared times by the reciprocal of the first one, which is 1 over c. So the final answer, that's minus 2. The final answer is equal to minus t minus 2. Okay, minus t minus 2. That's it. All right, so that's the answer for the gradient when, with at point, point t with the parameter t. Okay, that is the gradient. All right, in terms of t. All right, okay. So we finished that. Now we need to move on to part C. What is part C? Find the equation of tangent at t and prove that the x-intercept of a of a tangent, the origin and the original point form an isosceles triangle. So I guess what we need to do is find the gradient of tangent at a point t. Okay, that would be the first step to do. All right, the gradient of tangent at point t. Okay, so where do we start? Okay, we know that dy over dx, dy over dx is equal to minus 1 over t squared. That is the gradient, 1x equal 1, with the parameter t there. Then we can actually find the equation of tangent. So the equation of tangent, it would be y minus c over t, because we have a point t, which is ct, c over t. So y minus c over t is equal to negative 1 over t squared, x minus ct. That's the equation of tangent. But then we need to find the x-intercept of that tangent. That means we need to let y equal to 0 to find x-intercept. So minus c over t is equal to minus 1 over t squared, x minus ct. All right, so we need to find the value of x here. Okay, so how do we solve this equation? I guess the first step to do is you can actually times both sides by t squared. So that gives you negative t squared. So it gives you ct is equal to x minus ct. It's just that easy. So x is equal to 2ct. Okay, all right, so if you don't see the reason, just multiply by here, by t squared, multiply by negative t squared, and you can multiply by negative t squared to the right hand side as well. All right, and that's what you do. It gives you the answer on this side. All right, so x is equal to 2ct. That would be the x-intercept. Just write down the x-intercept then. All right, so the point A, we have 2ct and 0. All right, next we need to have the origin. Okay, origin is equal to 0 and 0. And then the original point t is ct and c over t. All right, so with these 3 points, what we need to show is, let me just copy this one here first. We need to show that gives you an isosceles triangle. All right. Okay, so let's see how does this one gives you an isosceles triangles here. So if it's an isosceles triangle, it looks like we need to find the distance. Okay, we need to prove that is an isosceles triangle. So we need to find the distance of AO, AT, OT. So we're going to find AO first. All right, AO, the distance is pretty easy, okay? It's actually extremely easy. You can use the distance formula, otherwise it's just equal to 2ct, okay? If you want to find TO, that's ct minus 0 square plus c over t minus 0 square and a square root. So that gives you c square t square plus c square over t square and a square root. Okay, it doesn't look like they're equal to 2ct. All right, anyway, it doesn't matter. We can do another one. Then we'll do AT. Now, AT is 2ct minus ct square, using distance formula again. 0 minus ct square root. So it is, you can see, that gives you the same answer of TO. That's pretty cool, right? So we get the same answer here. All right, so it seems we don't need to really simplify. All right, there's no point as long as we can show that AT is equal to TO. Since AT is equal to TO, therefore triangle AOT is an isosceles triangle. Okay, all right, so that is question 15, the last question of this exercise, apart from, the enrichment, okay? Shouldn't be that hard. It's just using the application of how to differentiate negative, differential expression with the negative powers there. Pretty straightforward, all right? Some questions are quite interesting. Now you can start to do some of the exercise I said online, okay? Thank you.